guys, in this tutorial, we will review some of the concepts from the previous tutorial, which is called Numpy Basics Part 1. So in particular, we will go over 8 exercises that review some of the concepts that were covered in that tutorial. So let's get to it. All right, so again, the purpose of this tutorial is just to review some of the concepts that they were presented on the Numpy Basics 1 tutorial. So we will create some Numpy arrays and we will perform some basic operations with them, okay? So let's start with exercise 1. So in this exercise, we are expected to create an array with 15 elements, and then we will reshape that into a 3x5 matrix or into a 3x5 2D array. So anytime that we're going to, or that you are planning to use NumPy, you first need to load the library. So we start by import NumPy as MP. And then after that, so let's create an array with 15 elements. So let's use just MP random and then run n 15. Then let's print it. So basically what we're doing here is just creating a 1D array with 15 elements. And the values that you see here are values from the standard normal distribution. That's the run nt. Okay. Now, so as you can see, so before we convert it into a 3x5, we can see that the shape here of this array is a 1D array with 15 elements into it. And if we want to convert this into a 3x5 matrix, so we just need to use the reshape option. So x dot reshape 3,5, and that reshapes the rate into a 3x5. And now if we want to store this result or this new 2D array, we will need to create, let's say, y is equal to that, and then we print white. And then now if I do y shape, so it's a 3x5. So yeah, so then this particular exercise just highlights how we can use reshape as a way to, in some sense, reshape the dimensions of the NumPy array. Exercise 2 is asking us to replace all the odd numbers in a NumPy array from 0 to 9 with -2. So first, what we need to do is we need to create an array with the integers 0, 1, 2, 3, all the way up to 9. And then all the odd values, we will replace it with -2. So let's start by creating the array first. MP arrange. Then if I just do that, so that creates an array with the integers from 0 to 9. Now the goal is to replace all the odd numbers with -2. So then basically we want to replace 1, 3, 5, 7, and 9 with -2. Okay, because those are the odd numbers there. So in order to identify odd numbers, we can rely on the modulus operator. So if I do this, so basically what I'm doing here is this is x percentage 2, so that's the modulus operator, equals to 1. So then basically is dividing each element by 2, each element of x by 2, and looking into the remainder. So if the remainder of that division is equals to 1, then that means that that value is odd. Okay, so it is returning false if this is false, or in other words, if the value happens to be even and is returning true otherwise. Okay, now if I want to actually see those values, so what I need to do is the following. So it will be x, and then x percentage 2 equals to 1. So that basically what it does is just selecting all the add values from the array called x. Now, if I want to set those values equal to some specific value, which in this case is -2, I just need to do this equals to -2. Okay, and now if I print x here, now I see -2 here, -2, -2, and -2. Okay, so this exercise just highlights how you can, in some sense, perform slicing, right? We're selecting some of the values from a given array, given some sort of criteria, and then updating those values with some predefined value, which in this case is just -2. Okay, exercise 3. So in this exercise, we first need to create a 5x5 2D array with values from 25 to 49. And then we're going to extract all the values from that array that they are greater than 35. So let's just start by creating the array first. So np arrange. So then in this case, we're going to start at 25, and then we want to stop at 50. So if I do this, it has all those values from 25 to 49. Now I need to reshape this into a 5x5, so I can quickly just add the reshape command here, 5x5. Now I have my 5x5 array with the values from 25 all the way to 49. Now, if I want to extract all the values or all the elements of the array X that they are greater than 35, so I just need to do the following. So X square bracket X greater than 35. And it prints all these values because all these values happen to be greater than 35. So this is just another way or another concrete simple example that highlights how you can slice and dice your array. Yeah. Exercise 4. So then here we need to create a 1D array with 10 elements, and then we're going to reverse it, okay, using slicing. So basically, so let's create an array. So random, let's use rand n, so random values, 10 values of those, okay. And then what we want to do is reverse this. So basically now the last element will become the first element, the second last will become the second element, and so on. So for that, if you want to reverse an array, so what you need to do is double square bracket notation, colon, colon, -1. Oh, oops, it's a typo here. Invalid syntax. So let me see. Yes, I think that should work. Oh, no, it's no double brackets. It's just single brackets. Okay, so single square brackets, colon, colon, -1, that reverse the values or reverse the orders of the values of the 1D array. So they notice that initially 1.19 was the last value, and now 1.19 is the first value. Okay, so this is a very important command. In some scenarios, you will need to quickly reverse your or the values that are storing an array. So if that is the case, you can use this command. Exercise 5. So then we need to create a 3x5 array, and we will extract the third column. So let's do this as follows. So np random rand int. So let's use from let's select 50. So what are we doing here is we are generating random integers from 1 to 100. We're generating 15 of them, and we're gonna use them to create the 3x5 array. So Okay, so then here is my 3x5 array. And notice that all of these integers, they were randomly generated from 1 to 100. Now, if I want to extract the third column, so basically, again, it will be this column right here, 74, 64, and 35. I just need to do the following. Now, notice that I enter 2 here. Why? Because in Python, everything starts at 0. So if I type 0 instead of 2, so that will extract the first column. 1 refers to the second column, 2 refers to the third column, and so on. So always keep that in mind that in Python, everything starts at 0. So, okay. Exercise 6, so then it says create a 1D array with 10 values and compute the exponential of each of those values. So again, this is another exercise that highlights how you can rely on the Python implementation, in particular the exponential implementation in Python, to perform this type of operation. So let's start by creating the rate. So np random run, let's create 10 values of those. Okay, so then here is my array with 10 values that they were randomly generated from the normal distribution. Now we're going to compute we're going to exponentiate each of them. Okay, so it will be np x, and that exponentiate this, right? So if you're not familiar with the exponentiation function, basically that's just raising, or it's a constant raise to a value, right? Well, the constant is the Euler number, so that's 2.7172, and it keeps going forever, very similar to the pi number. And then so then we are raising the Euler number to each of these values that they are presented here. Okay, so exponentiation again is another of those functions or distributions, if you want to call it that way, from the statistic standpoint, that it always comes up. Okay, so you just need to be familiar, especially if you're working with skew distributions and things like that. So that's something to keep in mind. All right, exercise 7. So we need to create a 3x5 array, and then we're gonna swap the first and the last row. So basically, so once the array is created, then we want the first row to become the last row and the last row to become the first row. So that's basically what we're going to do. Okay, so let's start by creating the array, random run, and then 15, and then we're going to reshape this to 3x5. And then here is the original array. So then what we're going to do is we're going to move the bottom row to be the first row and the first row to be the bottom row. That's basically what we want to do here. Okay, so for this, we need to do the following. So we're going to be using a square bracket notation. So we want first row, so then that will extract the first row, and -1 will extract the last or the bottom row. Okay, and we want to swap them. So okay, so that should do it. So then notice that now the bottom row, it became the first row, and the first row became the bottom row. Okay, so then that's just a quick swapping of those two rows. Okay, again, this exercise highlights, you know, the concepts of slicing NumPy arrays. And the last exercise is just create two 1D arrays and perform arithmetic operations with them. So let's start with x is equal to np random rand. So let's use integers for this case just to make things easier. And let's create 10 of those. Okay, and then let's create another array. Let's use the same logic. Okay, so here we have x, here we have y. And now let's perform arithmetic operations. So let's add them up. So notice that the operation is performed element wise. So then Here we have 79. The reason why we see 79 because it's 3 plus 76, that's 79. 64 is because 48 plus 16, that's 64, and so on. Now, if I want to subtract them, yeah, so very similar, right? 3 minus 76, that's negative 73, and so on. We can also multiply them, right? 3 times 76, that's 228, and so on. We can divide them, and everything is going to be performed element wise. Okay. All right, now what if they don't have the same size? So let's do a very simple example that will highlight what happens. So then what if one of them has 5 and the other one has 7? So this is my new x, this is my new y. So what if I want to add them? Let's see what happens. So if I want to add them, so basically it's complaining that operation can be performed. Why? Because they don't have the same size. Basically, they don't have the same number of elements. And this is not only on addition. So if I want to subtract them, we will see the same type of error. Okay, so the moral of the story here is that anytime that you're working with 2 or more NumPy arrays, make sure that they have the same dimension. Okay, so then that way you will perform your operations as expected. So if they don't have the same dimensions or the same number of elements, in this case that we're working with 1D arrays, then you will run into error messages. Okay, again, this is just a very simple tutorial that it was more just to practice and just to see in action how to perform a few different operations with NumPy arrays. But yeah, so again, if you have data and then if you want to start working with the data and doing some analysis with it, so you can think of arrays as a way to store the data and to start doing some manipulations with it in some sense. All right, so that's all I have on this tutorial. See you on the next one.